Hi, my name is Colleen Naughton, and I'm a doctorate candidate in civil engineering at the University of South Florida. Today we will be presenting a webinar on community engagement and research based on our research for the USF EPA Center for Reinventing Aging Infrastructure for Nutrient Management. The outline for this webinar will begin with an introduction of community engagement and research based on current literature and our experience, followed by two case studies about how other doctorate students in our department, Kevin Orner and Emma Lopez, are engaging the community in their research, and then we will end with an overall summary. Beginning with the introduction, the EPA's request for application for their Centers for Water Research on National Priorities related to a systems view of nutrient management in 2012 that we applied to and were awarded in 2013 really emphasized community engagement and stakeholder involvement. They requested specifically research that identifies, engages, and utilizes members of the affected community of stakeholders in water management throughout the research project. And so what do we mean exactly by a community of stakeholders? The EPA defines community as a group of people with diverse characteristics who are linked by social ties, share common perspectives, and engage in joint action within similar geographical locations or settings. And stakeholders are one who is involved in or affected by a course of action. So examples of stakeholders in research related to water or nutrient management may be regulatory officials or municipalities, operators at wastewater treatment plants, consulting firms, business owners, and even more locally with the homeowners. So throughout our research with all these different type of stakeholders, we want to create a community of stakeholders that we will engage throughout the research process. Further, for the EPA's request for applications, over and over community is emphasized. They were requesting how we are engaging the community in making our research innovative and sustainable, as well as protect the environment and strengthen communities. And also, the EPA wants to know how we will engage local communities throughout the project, including outreach, as well as define the community engagement practices associated with the research in addition to the systems view and demonstration elements. And lastly, explain how we may broaden public engagement in water management and how this can enhance the likelihood of success in projects and in research. So this was requested through the proposal that we submitted and were awarded, and things that will need to be reported on in the future. Now looking more specifically about how community and stakeholder engagement make research more innovative, we can consult the 7 principles of innovative research, and the very first one is effective stakeholder engagement and collaboration that is initiated in the early stages of a project and maintained throughout the problem-solving process. So the problem-solving or engineering and research design processes you may all be familiar with begins with identifying a problem and then defining that problem and the objectives, and from there developing the research plan. And after the research plan is developed, you then go through collecting information, analyzing it, and then presenting findings and demonstrating a technology. After that, the research or design process may start again, where you refine that technology or design, or identify other problems related to original problem or research objectives. So something that is missing from both of these processes is the community engagement part. We know through consumer products that companies will consult focus groups where they may test a product out before marketing it to the mass public. And that is the same thing that needs to be done with research, except it needs to be throughout the entire process and not just at one point. So here is the research process, but with community engagement. We begin with identifying the problem, but also the stakeholders involved, like the wastewater treatment plant operators or local homeowners. And we may identify this problem through literature review or what we observe as issues in the environment, such as eutrophication of lakes or streams, and also go to these stakeholders or community with this problem, and they might help us see other parts of the problem that we didn't identify or help broaden or focus the problem. From there, we will be better able to define the problem and objectives. But after we have defined the problem, we must go back to the community of stakeholders to make sure that we defined it correctly, and from there, develop a research plan, and before implementing it, make sure to present it to the community of stakeholders for their feedback, and then we can implement that plan by collecting information. And often when we collect information, that is done through fieldwork, surveys, or through collecting water samples in the community, so we're engaging the community in the process, though sometimes it may be more lab-based. Like when we analyze the information, this may be one part of the process that doesn't necessarily engage the community as much, but we can, and there is an opportunity to do this if we want to teach the community and develop their skills through maybe analyzing water samples or building rain gardens like we will see in Emma's case study, and thus teaching them about the research process. So after we have analyzed our information, we'll then present the findings, and this won't only be presented to fellow faculty and students, or reports or journal articles that only may reach the academic community, but also to the community of stakeholders, and based on their questions and feedback, we may need to go back into the research process and collect information or analyze things differently to correctly address their questions, concerns, and needs. And after this, we may demonstrate the technology. And again, the demonstration of the technology should be done to the broader stakeholders and community, and not just at the university setting. And again, the research process starts, as we may have generated many new ideas for further research that is needed throughout the process. So we see through this diagram that we maintain a constant communication with stakeholders at all stages, and the research adapts and changes throughout each step of the research process. So what we may have seen as the problem before changes, and what we may have been our original research plan is different, but our resulting technology is also more sustainable because of this dialogue. However, as the EPA outlined in this diagram, there are different levels of community engagement, from outreach on the left in the blue, that may have been more of our traditional way of community engagement, which is we identify the problem, we develop the research plan and conduct the analysis, and then we may present the findings to the broader research community. However, this is more one-directional, and we are trying to move more towards consulting and involving the community and having that feedback that is bi-directional, and hopefully, eventually, where there is shared community leadership and participation between the community and researchers to the point where it is community-driven and they may be seeking external support. And so the outcomes, as we see in the purple on the far right, is research that reflects the needs and desires of the community and community leadership on issues of concern. So for an overall summary of community engagement research, the public health community-based research principles, guiding principles really help summarize this. First, recognizing community as a unit of identity and also as a resource and building upon their strengths to help our research and our projects succeed. So this is a collaborative partnership in all phases of the research between the community and between research that has mutual benefit for everyone. So this research isn't just benefiting us or our careers, but it's also helping the community and the environment. And it is a co-learning process. We are learning from our research and stakeholders, and so are others, and it may also empower these stakeholders, particularly addressing areas of social inequality. We know with environmental issues, sometimes that lower income communities may be more impacted by low air quality or water quality where the property values are lower. So our research can really help empower these communities to identify the problem and solutions. And this is a cyclical and iterative process, as we have seen in the research design diagram, where there is a lot of back and forth with the community of stakeholders, and the research is dynamic and adapts. And this thus helps promote sustainability of the research and potential technology or product. And we are making sure to disseminate the findings not just with the knowledge that we have gained, but what our partners have gained as well. So with that, I will close out the introduction and turn it over to Kevin Orner for his case study on how he incorporates the community in his research.
Thanks, Colleen. As Colleen said, my name is Kevin Orner, and I'm an environmental engineering PhD student here at the University of South Florida. I'll be presenting this case study on how I engaged and how I will engage the community during my research as part of the Thrust 1 of the EPA Center. Thrust 1C is focused on resource recovery at centralized wastewater treatment plants, and more specifically at the side stream treatment. To give a better idea of what I mean by side stream treatment, the figure displays a standard layout at a wastewater treatment plant. The effluent of anaerobic digestion is dewatered. The solids are disposed while the liquid, or supernate, is recycled to the head of the plant. This is called the side stream. This supernate has high concentrations of nitrogen and phosphorus, which makes it a preferable location for nutrient recovery. One technology that has been implemented at several wastewater treatment plants is struvite precipitation. Struvite contains magnesium, ammonium, and phosphate. Struvite precipitation recovers approximately 80% of phosphorus and 20% of nitrogen. One private company who has installed reactors for struvite precipitation is Ostara, which produces a nutrient-rich fertilizer called Crystal Green. In addition to nutrients, other resources that can be recovered include energy and water. Thus far, I have been able to engage the community in two general categories. The first is people associated with wastewater treatment plants, and second is technology leaders. Specifically for me, I've conversed with the previous and current plant managers at Howard Curran Advanced Wastewater Treatment Plant. Additionally, I've conversed with visiting professionals including Jose Jimenez and J.B. Neathling. Through the EPA Center, I have connections and can contact in the future, including staff at Ostara and the EPA Center Advisory Board. The first step in the research process was to define the problem and research objectives. Before community engagement, I planned to research struvite precipitation coupled with an innovative method of nitrogen recovery. After taking a tour of Howard Curran Advanced Wastewater Treatment Plant and conversations with technology leaders, I heard that nitrogen recovery is considered very costly at wastewater treatment plants because alternate processes to recover ammonia fertilizer, like the Haber-Bosch process, are more economically favorable. After community engagement, my research is now on the topic of struvite precipitation coupled with an innovative method for nitrogen removal and energy recovery. This innovative method is using a microbial fuel cell for nitrogen removal and energy recovery. Previously, microbial fuel cells used an organic fuel source. I'm investigating ammonium, which is not fully recovered in struvite precipitation, as the fuel or substrate for the microbial fuel cell. The next step in the process, which I have not yet pursued, is to develop the research plan for coupling struvite precipitation with the microbial fuel cell. I plan to receive feedback from wastewater treatment plant staff and technology leaders regarding my research plan. The third step is collecting information. This will include laboratory work to obtain samples and a survey regarding anaerobic digestion and side stream treatment, which I will send to Water Environment Federation subscribers. The fourth step is analyzing the information. In my case, I will analyze my laboratory results and share my analysis with wastewater treatment plant and technology leaders. The fifth step in the research process is presenting the findings. I'll engage the community through manuscripts, posters, and conversations, and receive feedback. The sixth and last step is demonstrating the technology. I plan to accomplish this by constructing a demonstration project at a local wastewater treatment plant, which will both serve as a larger scale model of that technology, but also serve as a tool to educate the larger community. Thank you for your attention. I hope that this case study was valuable to you. In line with the topic of this webinar, I welcome any and all feedback, positive or constructive, regarding this presentation and my research as a whole. Next, I'll pass off the mic to Emma Lopez to talk about her case study.
Thank you, Kevin. Hi, I'm Emma Lopez. I'm a graduate student working under the Research Thrust 2, which is Sustainable Management of Diffuse Sources of Nutrients. Okay, so following the same steps that Kevin identified in his research. And so for the first step, identifying the problem, we here in our local community of Tampa, nutrient impairment is an issue for the Tampa Bay. And McKay Bay is an embayment of the larger Tampa Bay, and a study done by the EPA showed how the residential land use contributes the most total nitrogen inputs to the bay compared to other types of land uses, such as highways or agriculture. And East Tampa is the largest neighborhood that actually drains to McKay Bay. So, in terms of identifying community of stakeholders, we've made ties with residents in East Tampa, specifically community leaders and homeowners, as well as community organization like the Corporation to Develop Communities of Tampa, Inc., which I will say from now on as CDC, and the Tampa Vocational Institute. So, in defining the problem and research objectives, we know that we have stormwater runoff carrying nutrients to McKay Bay. We see flooding in East Tampa, and one of our objectives for our research thrust is to prevent and reduce coastal eutrophication. So some of the things that we started doing from the beginning is to have meetings with our community leaders and organizations such as the CDC on how to address these issues in terms of stormwater and nutrient management within the community of East Tampa. So we saw that there's a need to try to increase the awareness about low-impact development technologies that we have that can help in removing the nutrients from stormwater, such as rain gardens and using other LIDs such as rain barrels as part of community demonstrations. And we saw an opportunity to integrate these concepts in terms of green stormwater infrastructure and nutrient management with a course that of construction course through the Vocational Institute, which is a program under the CDC. And for step 3, to develop the research plan, we said, okay, let's install these rain gardens and bioretention cells for research. And we want to have 2 designs where we can compare how these 2 designs perform in the field at removing nitrogen from stormwater. So we've held meetings with the CDC from the beginning. We had conversations with our community leaders on how we can integrate our research with the community of East Tampa. So after this engagement, we decided, well, let's install one of our field scale sites in East Tampa, and let's incorporate the Tampa Vocational Institute participants to help construct and build these LIDs as part of their experience in their construction course. And we decided to install a rain garden at a community member's house and use that as a research site as well in terms of maintenance and preference of plants that go in the rain garden. So for step 4, collecting the information, we have our field sites where we plan to, and we're collecting samples of our influent and effluent coming out, and also samples of the plants in the rain gardens and see which ones perform better at survivability and removing nitrogen. And so we talked to the residents and employees that work at the CDC about the purpose of rain gardens, rain barrels, and its aesthetic appearance, and we've learned that they really don't know what these LIDs are meant and how they protect the environment and the purpose of these. So we saw that we have to install signage. So that's one of the things that now we're going to addressing, having signage that describes the purpose of rain gardens and why is there a PVC tubing sticking out of the ground. And this is because it's a research site, right? So we need this to take our samples, and all this will be included in the signage. As well, that we learned that Florida native plants are not as appealing to the residents of East Tampa as our other common and maybe colorful plants that have more flowers. And so the Florida native plants a lot of times are mistaken for weeds. So this is also something that we learned after engaging with the community members. So for step 5, analyzing the information, we plan to analyze our results and see which bioretention system design that we have in the field is working better, and which plants are the ones that are surviving under the conditions of the bioretention system, and which ones are doing better at removing nitrogen. And so we plan to discuss this with residents in the community and see what type of plants will be best for them in their rain gardens in terms of protecting the environment and removing the nutrients from the stormwater. And we plan to seek input from community members as we have through all the other steps and our local community organization with our research. So we'll see what happens after that in terms of after our community engagement for our step 5. And for step 6, in presenting the findings, we plan to have conversations, present our research in conferences. We also want to have pamphlets that we can give out to community members with this data on terms of rain gardens and what plants work better, what designs work better, and seek the input from the community. And in East Tampa, there's a lot of churches, so we plan to be able to work with the churches in the community and attend community events, as well as present our work in the local newspaper and radio stations. And for step number 7, demonstrate the technology, we actually made sure from the beginning that our research sites are demonstration sites, so we've already covered this step with our work that we're doing by installing rain gardens and bioretention systems in the community, as well as other LIDs such as rain barrels. And we're working and engaging community leaders as well as participants of the Tampa Vocational Institute who are residents of East Tampa in the demonstration projects. They've helped to install both rain gardens that we have and install the rain barrels as well. And one of our community leaders, Mrs. Evangeline Best, from the beginning she expressed interest in being able to showcase her yard to the public so that people could come and see how she implemented low-impact development technologies into her landscape. So we held this community event where people came and engaged with us, with the Tampa Vocational Institute participants, and learned about rain gardens and rain barrels and how they could install these in their house and different types of Florida native plants. And so from this, we see that there's also a need for the vocational students going through this program in being able to find employers that can hire them that are specifically looking for the skill sets that they're learning through our program. These skills in terms of green infrastructure and stormwater and nutrient management and the installation of rain gardens and rain barrels. So I hope that from this case study you're able to learn something and how you can apply this to some of the work that you're doing with your local community and community engagement. So now I'll turn it over to Colleen for a summary.
Thank you, Kevin and Emma, for your great case studies. Bringing it back to the introduction with community engagement and research, we saw through the 2 case studies how both Kevin and Emma engage or plan to engage the community of stakeholders in different ways throughout the research process. Kevin's research is more lab-based or associated with wastewater treatment plants, and Emma's is more in the field interacting with homeowners, but they both engage the community. They engage the community from the very beginning by identifying the problems and the stakeholders. Here are some references we used throughout the presentation. And I know we had a lot of text on our slides, so feel free to rewind this webinar, watch again, and pause, or consult the references for further information. With that, I'd like to acknowledge the EPA, our specific center that was awarded under the STAR program for Centers for Water Research on National Priorities related to a systems view of nutrient management is RAIN Management, the Center for Reinventing Aging Infrastructure for Nutrient Management. And with this EPA center, and also under an NSF PIRO grant, we have created a global network, RECLAIM, which is a network of researchers and practitioners dedicated to developing geographically appropriate and culturally relevant engineered systems to recovering nutrients, energy, and water resources from waste. That is the logo that you see at the bottom right of the slide. For further information on our research related on these two grants under NSF and EPA, you can feel free to visit our website, and also for more information specifically on community engagement, you can visit the community engagement link. Thank you for your attention, and I hope this was useful for you.